Basic electrical engineering. In previous videos we had studied about the temperature coefficient of resistance and some more numerical problems. In this video we are going to learn about the series resistance and some numerical problems on series resistance. Resistance in series. Resistance is the most commonly using component in electrical and electronic circuits. It can be connected in different ways along with sources. Sometimes it is connected in series and parallel and the combination of series parallel. Why this the concept of the resistances in series and parallel are those? Because of that, it is necessary to reduce these circuits into a simplified form. The techniques of reducing these circuits to simple forms are known as simplification techniques. There is set of rules for finding the equivalent resistance of series and parallel connections in a resistors. Here this is the resistances in series. If one end of a resistance is joined with another end of resistances, then they are said to be connected in series. In series, there is only one path to flow the current. Here it is a water analogy. This is a R1 and R2 are the resistances. Here battery is used to connect these resistances are in series and battery is a source. Here due to potential it is flows. Consider this water analogy system. 3 pipes of different sizes and entering and leaving water quantity is same. The pressures are different. In different sizes. Here these are the water analogy system. 3 types of pumps are used of different sizes. Due to this, what will happen? The entering and leaving water quantity is the same, but the pressures are different. Due to that pressure, if it is low volume, then the pressure is high. The pressures are different in different sizes. Similarly, 3 resistance having different resistances are connected in series. The potential difference to all of them is V volts. V volts causes same current I to flow in each of them. But the potential difference across each of them will be different. Here V1, V2, V3 are the three different voltages. The sum of V1 plus V2 plus V3 is equal to V. But V1, V2, V3 are not equal voltages. In water analogy, we are using three different types of pumps, different sizes. Inlet and outlet waters are same. Due to the different in sizes, the pressure build up in the pumps are different. The pressures are different at different sizes. Like that. Here V1, V2, V3 will be voltages across R1, R2, R3. A source V is applied to it. Capital V is equal to V1 plus V2 plus V3. Here only one single path is there to flow the current in that. So apply Ohm's law across each resistance. V1 is equal to I into R1, V2 is equal to I into R2, V3 is equal to I into R3. The total voltage is V is equal to V1 plus V2 plus V3. If we add this drops, IR1 plus IR2 plus IR3. Then IR is equal to I into R1 plus R2 plus R3. Cancel this I. Then R is equal to R1 plus R2 plus R3. Resistance of three resistances are connected in series. I is equal to current flow in all the resistance. V is equal to applied voltage. V1, V2, V3 are the voltage across each resistance. In general, if n number of resistors having resistances, total resistance R is equal to R1 plus R2 plus R3. This is a numerical problem. Depend upon by using these formulas we are going to solve these problems. So here the final conclusion is the applied voltage V must be equal to the sum of three individual voltage drops. And for the equivalent circuit, it is seen that total resistance RT is equal to R1 plus R2 plus R3 and so on. What is the conclusion about this topic? From the above discussion, our series circuit, we conclude that here same amount of current flows through each resistance. The applied voltage is equal to the sum of the individual voltage drops. V is equal to V1 plus V2 plus V3. the equivalent or total resistance is equal to the sum of the individual resistances. R equivalent is equal to R1 plus R2 plus R3. Here different resistances have their individual voltage drops. The voltage drop across individual resistances is directly proportional to its resistance. These are the conclusions we are observed from these resistances in series. What are the applications of these series circuits? The series circuits are commonly in electrical equipment. All current controlling devices are connected in series with the controlled equipment. Fuses are connected in series with the equipment they protected. Like that. And a thermostat. Thermostat switch is also in series with the heating element in an iron, electrical iron and heaters like that. And rheostats are connected in series with the winding in electrical machines for controlling current. Overall, by series, what we are learning in series circuit, all are non-circuit. All the bulbs or whatever, all the things are connected in series. If we are giving supply to it, either everything operates or nothing operates. For example, if any one of the bulbs or any one is removed, then the electrical circuit stops operating. Let's see different numerical problems on that. Here the first problem is two resistances 40 ohms and 20 ohms are connected in series across a 240 voltage supply. Find the current flowing in it and the voltage across each of the resistance. Here R1 is equal to 40 ohms, R2 is equal to 20 ohms, V is equal to 240 volts. What is the equivalent resistance for a series? For equivalent resistance of a series, R is equal to R1 plus R2. Here they are given R1 is equal to 40, R2 is equal to 20. So R is what? Combination of R1 plus R2 is equal to 60 ohms. Current I is equal to V by R. This 240 by 60 gives 4 amperes is the answer. Next, we have to find the individual drops. Here V1, V2 we have to find. So V1 is equal to I into R1, V2 is equal to I into R2. So 4 into 40 and 4 into 20. So 160 and 180 voltages. These are the final answers. In this, what we are learned is voltage the applet voltage V must be equal to the sum of the three individual voltages V1 plus V2 plus V3, and the equivalent resistance of these resistances are in series. R is equal to R1 plus R2 plus R3. According to Ohm's law, I is equal to V by R. Here, by using this Ohm's law, if we are finding the values of drops, then I1 is equal to V1 by R1, I2 is equal to V2 by R2, I3 is equal to V3 by R3. These are the points we have to remember. By using these simple formulas, we are going to solve the remaining problems. Let's see here, this is a problem. When 10 ohms, 20 ohms, 30 ohms are connected in series, calculate the equivalent resistance. Here what is the formula for the equivalent resistance? R is equal to R1 plus R2 plus R3. So 10 plus 25 plus 30 gives 65 ohms. This is a formula to find the equivalent resistances when the resistances are connected in series. Next problem. When 15, 20 ohms are connected in series across 20 voltages DC supply. Here this is a DC supply of 20 voltages. Here R1 is 15 ohms, R2 is equal to 20 ohms, and V is equal to 20 voltages. The question is to find the value of V1, V2 and R equivalent. Just read one more time this question. When 15 ohms, 20 ohms resistance are connected in series across 20 voltages DC supply, determine the equivalent resistance and potential difference across each resistance. Here V is equal to 20 volts. R equivalent is equal to R1 plus R2 is equal to 15 plus 20 is 35 ohms. First, to calculate the current according to Ohm's law, I is equal to V by R. So here in our question, this V is given as 20 volts. This R1 and R2 is 35. So 25 by 35 gives 0.57 amperes. Now we have to calculate the potential difference across this 15 ohms resistance and 20 ohms resistance. So 15 into I is 0.57. This gives a product and this gives this product. Next problem. What is the value of an unknown resistor connected in series with a resistance of 24 ohms if the potential drop across 24 ohm resistor is 72 volts and the across the farmer is 48 voltage? This is an indirect question. We have to study it carefully. Here they don't know the value of this R2. We have to find the value of this R2. This is the question. Right here R2 is the unknown resistance. R1 is equal to 24 ohms. They are given in our given data. Now we have to find the potential difference across this 24 ohms. Here V1 they are given as 72 in our question, right? V2 is equal to 48. R1 they are given as 24. We don't have to find the value of R2. We know all the values, just we don't know the value of R2, that we have to find. I is equal to V by R according to Ohm's law. Here I is equal to V1 by R1. V1 they are given as 72 and R1 is 24 ohms. This is 3 amperes is the answer. Next, R2 is equal to, we have to find what is the value of this R2 according to Ohm's law. R2 is equal to V2 by I. So 48 by 3 gives a 16. The unknown value is 16 ohms. This is the answer. Next problem. 3 resistors 10, 15, 25 ohms are connected in series across 20 voltages DC supply. Find the potential difference across each resistor. V1, V2, V3. R1, R2, R3. 10, 15, 25 ohms. V1 is equal to 20 volts. We have to find the value of V1, V2 and R equivalent. Equivalent resistance of the circuit R equivalent is equal to R1 plus R2 plus R3 is equal to 10, 15 plus 25 is equal to 50 ohms. This is the formula. This is the formula we are used for our equivalent resistance of series circuit. By this is a 10 ohms, this is 15, this is 25. Add this 10 plus 15 plus 25, we are getting our total R is equal to 50 ohms. According to Ohm's law, I is equal to V by R. V they are given as 50. So I is equal to R, we are finding our R as 50. V they are given the V value as 20, right? It is 20. So here here 20 by 50 gives the I value is equal to 0.4 amperes. Potential difference across 10 ohm resistor. V1 is equal to I into R1. 0.4 into 10 is equal to 4 volts. Next, potential difference across 15 ohms resistors. V2 is equal to I into R2. We substitute the value of I and R2. This gives a 6 volts. Like V3 is equal to I into R3. Our I value is 0.4, R3 is equal to 25. We are getting the value of 10 volts. Next problem. Three resistances 8, 12 and 6 ohms are connected in series across an unknown voltage source. The potential difference across 12 ohms resistance is 18 volts. Find the unknown voltage source. Here R1 is equal to 8 ohms, R2 is equal to 12 and R3 is 6 ohms. V2 is equal to 18 volts. This is a question. They are asking the unknown voltage source. They are asking the value of V. Here this is the question. The equivalent resistance of a series circuit is R1 plus R2 plus R3. 8 plus 12 plus 6 is equal to 26 ohms. Next, current through 12 ohms resistors is, according to Ohm's law, what? I is equal to V1 by R1. 18 by 12 is equal to 1.5 amperes. Here this is a series circuit. Throughout the circuit, the current value is 1.5 amperes only. The current value is same throughout the circuit. I into R equivalent 1.5 into 26. Gives 39 volts. Now, equivalent resistance in the here the resistances are in parallel connection. Here three resistances R1, R2, R3 is connected parallel. Parallel means what? The positive ends are connected at a junction and the negative ends of all the resistors are connected at another junction. Here we observe that current I is equally divided into I1, I2 and I3. Resistances in parallel. In parallel resistances, the voltage is same throughout the circuit. The potential difference across all the resistor is same, but the current in each resistor is different, and it is given by Ohm's law. So overall, by observing this, here V is same throughout the circuit. I is the sum of I1 plus I2 plus I3. This is a parallel circuits. Here this is a battery, or take it as pump also. These are parallel. Observe this figure. I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R3. Total current I is equal to I1 plus I2 plus I3. Here R1 and R2 are the three resistances are connected in parallel. So the equivalent resistance formula we have to see. First, according to Ohm's law, I is equal to V by R. V by R is equal to, here first we are taking it as I is equal to I1 plus I2 plus I3. So what is the value of I1? I1 is equal to V by R1. I2 is equal to V by R2 plus V by R3. According to capital I, what is the value? V by R. V by R is equal to V by R1 plus V by R2 plus V by R3. In this above equation, we have to take the common value of V. Cancel both the sides. Then 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the equivalent resistance when the three resistors are connected in parallel. Here this is the resistances are connected in parallel. So overall, to simplify our circuit, we have to take the equivalent resistance between any 2 points is given by the single resistance, which can be replaced by the entire circuit between these 2 points. So equivalent resistance. Here conductance is reverse of the resistance. The symbol of conductance G is G. G is 1 by R. These two are reciprocal with each other. G1 is equal to 1 by R1. G2 is equal to 1 by R2. G is G1 plus G2 plus G3 and so on. Just observe from the above discussion, if the resistances are in parallel, the main characteristics of parallel circuits are same voltage flows across all the parts of the circuit. Different resistors have their individual currents. Branch currents are additive. Conductance are additive. Powers are additive. These are the points we have to observe in our parallel circuits. Let's solve one problem. Here three resistance 10 ohms, 15 ohms and 20 ohms are connected in parallel. What is the equivalent resistance? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Is equal to 1 by 10 plus 1 by 15 plus 1 by 20. So the total equivalent resistance is 4.6 ohms. This is the final answer. Here which formula we are used? We are used this simple formula. 1 by R is equal to R1 plus R2 plus R3. Let's see another problem on three resistances. 10, 15, 20 are connected in parallel. Find equivalent resistance. Here R equivalent is equal to R1 into R2 into R3 by R1 R2 plus R2 R3 plus R3 R1. This is the formula for the three resistances are connected in parallel. 10 into 15 into 20 by 10 into 15 plus 15 into 20 plus 29 into 10. The final answer is this. Here we are calculating the equivalent resistance. Next model. Three resistors 25, 15 and 10 ohms are connected in parallel across 20 voltages supply. Find the current in each resistor. Here I is I1, I2, I3. So capital I is equal to I1 plus I2 plus I3. The resistance current flow through 20 ohms resistor I1 is equal to 20 by 25. I2 is equal to 20 by 15. I3 is equal to 20 by 10. Let's see. (20 by 15 and 20 by 10). These are the answers. Next, three resistors 100, 150 and 175 ohms resistors are connected in parallel across 200 voltages supply. Find the total current flows in the circuit. Here R1 is equal to 100, R2 is equal to 150 and R3 is equal to 175 ohms. This is the question. V is equal to 200 voltages. In that question, what they are asked? They are asked to find the total current, capital I value. What is the value of this I? That is the question. Here R equivalent. They are finding current I is equal to V by R equivalent. 200 by this gives the answer. What here we are done? Just we are used the simple formula R equivalent. We are finding. Instead of this complete resistance, we substitute with a single resistor of 45.16. Then 200 volts. To simplify our circuit, we are taking the value of this equivalent circuits of the resistances are connected in series and parallel like that. By this I is equal to V by R. 200 by 45.61 gives 4.35385 is the value of the current flowing in the circuit. Next, three resistance 15, 25 and 10 ohms are connected across an unknown voltage source. Here the question itself is it is unknown voltage source V. We have to find the value of V. Current flows through the circuit is 3 amperes. Find the unknown voltage source. This problem is very simple. They are given I value, R1, R2, R3 value. Immediately what we have to do? I is equal to I1 plus I2 plus I3. right, is equal to what? I, 3 amperes. We have to find the value of I1, I2 and I3. For finding this, first we have to calculate the value of equivalent resistance. This is a formula for our equivalent resistance are connected in parallel. By using this, we are getting the value. According to Ohm's law, I is equal to 3 amperes they are given. According to Ohm's law, V is equal to R into I. Then this is the final answer for this question. They are given R1, R2, R3 values, I value. Their question is to find the value of V. V, according to Ohm's law, V is equal to what? IR. V is equal to IR. Here R, we have to take its equivalent resistance. The formula of equivalent resistance when it is connected in parallel are R1 R2 R3 by R1 R2 plus R2 R3 plus R3 R1. By using this, we simply replace our circuit. By 4.84 ohms. Here the current flowing is what? 3. So according to Ohm's law, V is equal to IR. Here I is equal to 3, R is equal to 4.84. Gives the 14.52 is the final answer. This is another problem. Two resistances 150, 100 are connected in parallel across 100 voltages. DC supply. Find the current in each resistor and the total current flows through the circuit. We are finding the equivalent resistance. The formula used is R1 into R2 by R1 plus R2. According to Ohm's law, E is equal to V by R. By this formula, we calculate the value. Next, I1 is equal to V by R1, I2 is equal to V by R2. We substitute the value of these two. Then we get the answers of this. Let's see the comparison of series and parallel circuits. In series circuit, current is the same. In parallel, voltage is the same. In series, total voltage is sum of the individual voltages. Here in parallel, total current is the sum of individual currents. Total resistance RT is equal to R1 plus R2 plus R3 so on. Here total conductance GT is equal to G1 plus G2 and so on. These are the comparisons in our series and parallel circuits. Current same means I1 is equal to I2 is equal to I3 is total I. Voltage same is V is equal to V1 is equal to V2 is equal to same. In series circuit, current is same throughout the circuit. Only single current flows in a path. In parallel circuit, voltage differences across every resistance is same. Same voltages flows in our circuit. In series, total voltage is sum of all the voltage drops. Here the total current is sum of all the currents. And the last point is I is equal to V1 by R1 and V2 by R2 or V3 by R3. Here V is equal to I1 by G2, I1 by G1 or I2 by G2, like that. In this video, we are covered the topics of series and parallel resistances. In series resistances and in parallel resistances, the comparisons and the many more numerical problems available. We have to solve so many problems in this chapter under series resistances and parallel resistances. In this method is we have to calculate the equivalent resistance. Why we have to calculate the equivalent resistance? To simplify our circuit. Right. So equivalent resistance of series and parallel and total current flows in the circuit series and parallel combinations, like that. These are the things we are learned. In continuation to that, then our next video we are going to cover the parallel and parallel combination, series and parallel combination circuits and current and voltage division rules. You have to solve some more problems available in your textbook. Thank you and thank you for watching this.